So today we are looking at similar polygons. So we have already talked about congruent figures, and just a refresher on congruent figures that they have to have the exact same size and the exact same shape. So when we look at similar polygons, the difference with similar polygons is that they have the exact same shape, but they are different sizes. So the big thing, this is huge, okay? This is the thing that people are going to have to come back to time and time again is polygons are similar if. And so these two bullet points are vital. One, your angles have to be congruent, okay? So just like with congruent figures, angles are congruent with similar figures. The second thing, and this is the one that is different, is that your sides of congruent figures, they are no longer congruent, but they are proportional. Okay, and we're going to do plenty of examples using that second piece especially. So the ratio of corresponding sides is called your scale factor. And then the last thing here, if polygons are similar, then their perimeters also are proportional. Now, here's the thing, guys, that last bullet point, that's just kind of like the cherry on top. That's really not a major focal point, but it is something to kind of keep in the back of your mind. So for the scale factor, the big thing that people are going to overlook is that order 100% matters. So when you are looking at the scale factor of ABC to DEF, okay, one of the things to be mindful of is what I would recommend when you look at your picture and you're dealing with scale factor, I would pick out my smallest side of the first figure and the smallest side of the second figure, okay? We're going to talk about those other sides later, but for the scale factor ones, you already know that the triangles are similar. So we can go ahead and do ABC. So the number that we're pulling off of that first triangle is the 8. And then 8 to 12, and then that can simplify. And when we simplify that, it becomes either 2/3 or 2 to 3 if you leave it with those colons. If you notice, the second one, very similar. The only difference is the order is backwards. So instead of 2 to 3, it's going to be 3 to 2. Okay, so again, if you wanted the setup, you would pick the 12 out of that second triangle, pick the 8 out of the first triangle, and then simplify. Now, in terms of that last piece here, what's the ratio of the perimeter of DEF to ABC? 100%, you could absolutely find the perimeter of each to help you out. So if you look, perimeter 8 plus 18 plus 10, so 8 plus 18 plus 10 is going to give us 36. For this one, your perimeter is 12 plus 15 plus 27, which gets us 54. Now the thing is, your order 100% matters, so you would do 54 to 36, but again, that simplifies to be 3/2. And so again, the perimeter matches up with that scale factor. It's still going to be proportional. Now, when we look at similarity statements, this is going to be our go-to. One of the things that we need to recognize is the symbol for similar is just the squiggle. We've just kind of as a refresher, the symbol for congruent was the equal with the squiggle on top. So no longer do we have that equal piece, it's just the squiggle. A valid similarity statement must match corresponding angles and sides. So in other words, order matters. Okay, so just like when we did congruency statements, for similarity statements, order matters. So if we pick out that first triangle, we can name the first one however we want. Triangle ABC is similar to triangle. And if we notice, we have the things marked. So if we look, A is marked with 1 arc, so D is going to match. B is marked with 2 arcs, so E is going to match. And then we have F as our final point. Okay, but again, order 100% matters. So when we look at these examples, we're not going to do every example on your notes, so just a little disclaimer there. So if you're matching up angles, again, just a refresher that the angles are going to be congruent, sides are proportional. Okay, so when we look at this, what we're going to be doing is we can go ahead and pick out our corresponding angles. So we've got angle J, angle K, and angle L. And guys, here's the thing. I am using these 100%. I'm not even using these pictures. Okay, so I'm kind of ignoring those pictures. I'm just using the name. So angle J is going to match with angle P. Angle K is matching with angle M. And angle L is matching with angle N. And so for the sides, the proportional piece of this, the way that you would write this is you're going to set up, remember, proportional just means that you have a fraction equal to a fraction equal to a fraction. And so what you've got going on here is JK corresponds with, and again, I'm using this name, so JK corresponds with PM. Okay, and then I'm going to come up here, and then I would have KL corresponds with MN. And then lastly, my JL, so the first and last, corresponds with my PN. And guys, here's what that looks like, because those are proportional. We're going to match up here. This is a matching pair of sides. Here, this is a corresponding pair of sides. Here, here's another corresponding pair of sides. But they're not equal. They're not congruent like we did with congruent statements. So you would have to set up those fractions and setting them equal. Okay? So take a second, try this on your own. This is not a matter of you guys typing it into Edpuzzle on this one. I just want you guys to try it. So again, when you guys look at your angles, I am only focusing on this. I'm not even looking at the picture. So I've got angle J, angle K, angle L, and angle M. And those are going to be corresponding to J was the first one, so Q. Then we have R, and then we have S, and then we have P. Your sides, the only difference with your sides is here on the one that we did a second ago, you had 3 ratios set up because there were 3 sides. Now you have 4 sides, so you're going to have 4 ratios. So you have JK is going to match up with QR. You've got KL matches up with RS. You've got LM matches with SP. And then you've got JM corresponding with QP. And so guys, again, I'm not using the picture at all. I'm using the names to come up with those. Something else to be mindful of, these do not have segment links over the top because you're looking at the measure of. So the measure of, you don't use the segment link over the top. Okay, so again, you have those sides, you have that they're proportional, so you are good. All right, so let's take a look at this. Using similar figures to solve for missing measures. If the figures below are similar with a scale factor of 2 to 3, find the value of x. So obviously 2 is the smaller number, and then this is the bigger number. And so this, if you look at your figures, this is the small figure and this is the big figure. So you want to be consistent. So the 2 is the same spot as the 42, and then the 3 is the same spot as the x, because your small figures are all on top, big figures are all on bottom. And so from here, we can just cross multiply. So you have 2x equals 42 times 3. And so 42 times 3 is going to give us a value of 126. And then when we divide by 2, you get a value of 63. Okay. When you look at this one, I'm going to let you guys try out number 5 for yourself. All right, I'm going to go over it real quick. So you've got 6 over 5. Again, the big is on the top, small is on the bottom. Okay, some people will be like, how do you know that? Well, think about it logically. 6 is bigger than 5. So this is the big triangle. This is the small triangle. And so you've got x is on top, 28's on bottom. And so when we cross multiply, you get 6 times 28, which is 168 equals 5x. Divide each side by 5. So you get an x value of 33.6. Notice, decimals are okay. Decimals are okay. So we're going to just finish off with a couple more of the odds. We're not going to do every single one. But if you notice, for number 7, you no longer have the scale factor given to you. Instead, you're going to have to come up with your own scale factor. So, for example, I'm just going to color this one in with red. I'm going to color in the bottom one with blue just to kind of keep it straight what I'm doing. So if we look up at here, this is going to help us. So YZ is 32, and if you notice, YZ is in the last 2 positions, so RS is going to match with that. Okay, and then you also have the remaining 2, and I'm just going to circle these. You've got 40 and 75 that match. Now, the reason I colored those red and blue is I'm going to keep the red on top, and I'm just going to do the whole problem in purple. So red on top, blue on bottom, just to kind of keep it straight what I'm doing. So 32 matched up with X. I boxed both of those. Again, I'm using the name up at the top to help me with that. And then my red, the 40 is on top, 75 is on bottom. Now you can do something other than red and blue. You can do like small over big if it's obvious, but I'm just showing you another way that you could go about setting this up. All right. So cross multiply this way, you get 40x. 32 times 25, or excuse me, 32 times 75 gets you 2,400. And so then when you divide each side by 40, you get an x value of 60. All right. So take a minute, try out number 9 for yourselves. Again, be careful with those expressions, those x plus 5s and the 4x minus 1. All right, so let's take a look. So again, I'm going to figure out what matches up. So TL is listed first and second, so CH matches. And then I've got 4x minus 1 and x plus 5 match. So if I do this, I'm going to do the left side over the right side, and then left side over the right side. Now you could have set yours up a little bit differently. What matters is when you cross multiply, you would have 25 times the quantity x plus 5 in one direction, and you have 10 times the quantity 4x minus 1 in the other direction. Okay, so again, you could set that up a little bit differently. I did the left over the right just to kind of help keep that straight. So now I go ahead and distribute. So 25x plus, and then 25 times 5 is going to give me 125. I get 40x minus 10, and then I subtract 25 to get 15x here. Add the 10 to get 135, and 135 divided by 15 is going to give us a value of 9. Okay, so as you guys are looking at this, the biggest thing I can recommend, 2 big things actually. 1, don't just set sides equal to each other. Okay, sides are not equal when we're dealing with similarity. You have to set up those proportions and cross multiply. The second piece is if the picture is confusing you, 100% use this. Okay, use that because that's going to help you figure out what your corresponding pieces are to set up your ratios. All right, guys, as always, ask questions. I'm sure they'll pop up, but hopefully that all made sense. So keep me posted on how I can help you guys.